Hello, everybody. Again, good morning, good afternoon. Thank you for joining. I'm Daniela Muente, Marketing Director at GNX, and I welcome you to the last live webinar of the year. We'll be talking about the key learnings and 2026 predictions for your global WAN. And I will quickly move to Rick, because as I said, we have lots to talk about. Please use the Q&A for questions. I believe the chat is off, but the Q&A should be active. So that's it. Thank you very much, and over to Rick. I go mute.
Thanks, Daniela. Thank you, everybody, for joining. Thank you again for being with us. If you're here for multiple times, we love doing these webinars, and it's great to see familiar faces being back and enjoying what we have to say. So I hope this will be as entertaining for you as the ones before. As we'd like to share with you today some of the trends that we've seen this year. And most importantly, what do we believe is going to happen by next year, by 2026? And I'll give a slight sneak peek of what we believe is going to happen by the end of the decade, by 2030 as well. So only 5 years to cover in 25 minutes. So let's get started with that. A lot of stuff has been going on. As you are following the news, following specifically news around global connectivity, you will see that a lot of these keywords have been popping up on your timelines in newsletters and in white papers that you may have read this year. I will pick out a few of those to discuss in a little bit more detail of some of the trends that we've seen this year happening around the world of global connectivity. And I take that very specifically, of course, because as GNX, we provide the best network underlay, the best global underlay as possible. So I'll focus the news a little bit on what are the options out there, what are the changes that we see happening with our customers. Some of this news will be searchable on the internet and public information. Other areas is where we really looked at the projects and opportunities that we worked on with our customers and potential customers this year, and what has changed this year versus others. And there were quite a few interesting key takeaways there that I'd love to share today. The main one that is quite a big change is a change that we only expected to happen by 2029, 2030, was that internet underlay, or DIA, so dedicated internet access, has taken over as the major connectivity source, as the major source of connectivity for large enterprises. In the past, this used to be a private connectivity type called MPLS. Now that technology has not gone away. Under most of these internet connections, MPLS will be in some part of the network, will play a role. But with MPLS, we mean private connectivity going to a site that is specific for your business, for your global enterprise, that every site is connected to that same, let's say, private cloud of connectivity that you have. The change is not massive. It's about like 51-52% currently, where internet is the dominant underlay for large enterprises. And this may come as a surprise to many, both positive and negative, in the sense that some may understand that large enterprises move very slowly, and that MPLS was still the majority factor, although other companies are, of course, have been on the internet as an underlay for many, many years. The drivers are pretty logical, are pretty open doors. The cost per megabit on an internet link is, of course, much lower than it is on a private MPLS link, although negotiable, of course, with your big telco. But the majority of the use cases here is the adjacency to clouds. How do I reach the new applications? Pretty much every new application that gets deployed has some form of SaaS component in it, or some form of cloud-enabled component in there, whether that's for authentication, whether that's your Microsoft 365, whether that's Salesforce.com that your salespeople are logging into. Everything has a cloud component these days, meaning that internet is remaining to be a more dominant factor. And like I said, we expected this overtake to happen only a few years from now. It's already there. And with that also comes a new mix of connectivity. In the past, you used to have, let's say, a primary and secondary MPLS link, and then maybe a tertiary internet link for really as backup. Today, a modern day branch office or headquarters even looks something like this, where on the primary side, you have a direct internet access link, which is dedicated bandwidth, guaranteed latency, and typically also a specific part of the ISP's network that is really suited for these business grade internet links. Then secondary is where our customers are now starting to pick more and more broadband for as a secondary link. So broadband differs from DIA in the sense that it is usually based on the same network as all the consumers are for an ISP, which is not necessarily a bad thing. But the problem is it doesn't give you guarantees. As you know, as a consumer of an internet link, if something goes down, you report the issue to your ISP. They will send an engineer, but when he will come, hopefully the next day, but when, you don't really know. So I always say that broadband doesn't really come with guarantees. Even if you get a contractual agreement, like some form of SLA with your ISP, that's great, but in the end, it's a piece of paper that promises something. And if it cannot be delivered, they usually take the penalty that they have to pay for that. So be very aware of choosing broadband as your secondary service because it can have impact on your continuity. And that is where this tertiary play comes in. Low Earth orbit internet connectivity has been sort of a newcomer, and it's been very explosive in its growth, both in launching new satellites, which happens with actual explosions, but also in the uptake that we see in how many enterprises make use of it. Starlink is, of course, the dominant player in this by SpaceX. They recently crossed, but by I think the launch they did about 2 weeks ago, they launched a rocket with more satellites, and that where they crossed now 10,000 active satellites in operation, which is a massive number considering that only like 10 years ago we had about 1,600 satellites all over the globe, and now we have only 10,000 that are just dedicated to Starlink itself, and it's rapidly growing. But more on that in the 2026 part of this presentation. Low Earth orbit is a great method of tertiary connectivity. It has bandwidth. It has definitely bandwidth that you can make use of. Not the highest as possible, but it's there. It's very stable, although there has been a few outages this year, but it's relatively stable. What we always say when you consider low Earth orbit, outages are very rare, but if they happen, they're blackouts, right? So if something happens, the whole network goes down globally, meaning that it's not like a regional fiber cut that impacts your site only. No, it's like a global outage that they experience. So be aware of that, and it's something you can plan for. And like I said, it always back it up with some primary connectivity. But that mix is something that we've seen enterprises start to play with more and more, and we see a lot of demand specifically in the low Earth orbit section. And then there's this promise then. So when you switch from a private connectivity backbone from a large enterprise with either MPLS or a big backbone that you connect with internet with, if you move that to a more flexible model where you make use of local heroes or local suppliers that deliver you the best connectivity that's out there, the problem is if you have your enterprises and your offices on different types of networks, the path between that will not be guaranteed. In a sense, they're using the internet, which is an unguaranteed, unpredictable network by design. It's just a widely interconnected web of different kinds of networks that grows together. There's no guarantees on the internet, and that's with reason. There are solutions there, but nothing that impacts the internet itself, because by law, the internet needs to be a neutral place. So you cannot really prioritize one customer over another across the globe. That's just not possible. And of course, there is a more pragmatic route for this. So some telcos promise you something that's called deterministic peering. What that means is that you will have two parties that agree with each other. So two large ISPs that agree with each other. Oh, for this customer, we'll set up a specific session between our networks that their traffic can flow across this, meaning we'll have slightly lower latency and slightly better quality connection. The problem is it's always going to be a shared link with other customers as well. So again, it's not the same guarantee as you would get on a private link, for example. So be very pragmatic about your choice there. Don't believe in buzzwords like deterministic peering. Using the internet has definitely a lot of positives, but it also comes with some concerns here. And with those concerns, one of those is latency. So one of our webinars we've done this year was about the essence of latency in a network, specifically when you use the internet. With the usage of AI applications like large language models and chatbots, latency becomes much more of a dominant factor here. First of all, because you exchange a lot more data between with this language model, and not only you with the language model, but now we're starting to come into this age of agentic AI, meaning you have agents that talk to each other and also exchange a lot of data with each other. So how do these agents talk to each other? Usually across the internet or across a data center between servers. So latency is, or low latency is no longer sort of a product that you buy, unless you're this high frequency trader that buys these extreme ultra low latency links. That is a product. What I'm talking here is that it's the network design choice, that you really have to plan. Okay, I need to deploy a site in Frankfurt. I need to deploy a site in Dubai. How do I get the best latency from site A to site B? And how does that impact my tasks that I need to do there? Different routes to get there. First of all, like I say, is reducing distance. So it's, are you planning in the right locations? The second is optimizing the path between it. Am I using, so the internet is, like I said, is an unguaranteed path. Asymmetric flows are very frequent. So it could be that traffic in one direction takes the path through, I don't know, from Dubai to Marseille to Paris to Frankfurt. And the other route could be Frankfurt through Poland, all the way terrestrial through Turkey, and then go down through the Gulf region. So that is a complete asymmetric path with different latencies that you will not easily spot if you do a trace route, for example. So how do I guarantee that my latency? Well, one way is with private connectivity, but most importantly, you just have to be aware that latency is an issue these days, specifically with AI workloads. And even more importantly, when agents start to do their job, they're very, they're only as effective as they can be with if you feed them the data. So if that data requires time, your agent is going to be less effective. It takes longer to respond, and then user experience goes down. And of course, we've seen resilience of the internet being tested in 2025. The first one, like volumetric DDoS attacks that are increasing ever and ever. I recently read an article about a DDoS attack that crossed the multi-terabit range, which is insane if you think about it. Only a few years ago, that would have brought down the internet as a whole. Today, we have a very resilient architecture that allows these attacks to be stopped very early. And we still have to plan for it, so it's very important to be aware of it, but there is some sort of resilience there. The more fragile part of the internet are the next two parts. Specifically in the Gulf region, we've seen multiple cuts for sea cables. This also happened in parts of Asia and also in the Atlantic Ocean. A couple of issues were there, but the major issues that are still happening is, for example, in the Gulf region, where the area is also too risky for even the repair crews to go out and repair the cables. So a lot of capacity is currently lost in that region due to this. This is a pretty invisible problem for a lot of enterprises because the link that you have in your office will remain up. It's just internet. The internet will still work. The problem is that your provider has a big issue in bringing your data back to Europe, for example, because that cable that they usually use as a primary path is now down. So they have to use an alternative route, which either has less capacity, it will probably have higher latency, and hopefully has the same quality as the other link had. So it's hard to plan for this because, of course, they happen infrequently, and it's pretty invisible if you're not following exactly where things are happening. And that is something that we help our customers plan for. We want to make sure that they use upstreams with different routes that are not bound to a single sea cable being cut with a big exposure. But that part of the internet is I think, in my opinion, the most fragile part that people are not really aware of. And then the third, and that actually happened very frequently, happened very recently, that is an outage caused by a hyperscaler. Hyperscaler, of course, being one of the big cloud parties. The first big one we had somewhere around May or June, where Microsoft Azure had a serious outage in one of their regions that brought down a big part of the internet because Cloudflare was hosting some of their resources there. And of course, if you know, Cloudflare hosts about 10% of the web traffic goes through their network. So if some things are happening there, you'd bring down a lot of key applications. The next big outage was last October. AWS had an outage in their first region, so US East. That was a key one, and I think a third of the applications on the internet felt it. People couldn't open tickets with Jira. People couldn't open games like Minecraft. There was a lot of authentication errors, all because of one single data center had issues. Imagine the impact if a more serious issue would occur in multiple of these regions. So plan for resilience. That is really what we're seeing in 2025. We see how fragile the internet is with their cable infrastructure. And of course, there's a lot being done to overcome this. And I'll come to that in a few minutes. But that cloud outages, that is going to happen more frequently as these hyperscalers keep on growing, keep on scaling. Outages will occur and will happen. So you really be sure about where your data is, where are you dependent on, which of these regions. You cannot plan for everything, but at least if you're aware that if something happens and you have a plan, then you're already better than 90% of your competitors. And then the final one is something that we saw in changing the way that customers ask us for global connectivity. With the ever-changing demands, for example, I've already spoken about AI usage. You exchange a lot more data with your large language model than you did before. In the past, I mean, I'm transmitting now this webinar through a single video stream towards many people. That is only one upload stream of bandwidth for me, and then it gets accelerated through the CDN of Microsoft to everybody watching. With video calls being the dominant way of communicating in the office with dozens of people on it, that is dozens of video streams that go up on a single link. Exchanging data with your AI model, as I explained, even this morning, what I mean with collaborative cloud workflows, this morning, I was editing this PowerPoint deck with our global brand manager, and I was working with her on a video call. We were editing this PowerPoint all live, all the text was edited. That is really powerful tool, but it also needs connectivity to work well, to be as effective. Otherwise, you get weird things and things overlap, and you get very confused very easily. And the reason I'm saying is that what we're seeing is that upload speed starts to matter a lot more than it did before. We even had RFPs and quote requests from customers that said, I don't really care about the download speed, just quote me based on upload speed. And I initially, when we first received this, I thought it was a bit odd because everybody asked for a certain download speed, but it makes a lot of sense. Specifically, if you look at DIA connections, so the dedicated internet access links, they're always symmetric, right? So upload and download is always the same. On broadband, that is not necessarily the case, but we can sort of say that when upload speed is at a certain level, download is either equal or higher. So quoting on upload speed is actually makes a lot more sense in that sense, but specifically for the growth in application usage here, that is becoming a much more dominant factor. Then on to 2026, what to expect for next year. I've teased a few of these changes already, but we'll see a big shift in how we see traffic patterns going. I've already highlighted this before. This picture is a little bit high level, but if you look at this from sort of like it's meant to like an AI training data center, but it's really meant as like two headquarters with branch offices, or you have multiple workloads that need to be synchronized with each other. The point is, distance matters between these big blue dots in the middle of the slide. Latency is absolutely key between those. If you are working on these AI models, or if you are deploying some of these applications, you will see that the lower the latency is between these nodes, between the agents, the more effective they become and the more useful they become for your users. And then the second part, as we trickle down our AI applications more towards the edge, meaning as close to the user as possible, you will see that, again, the only reason that is done is for latency reasons. The problem then occurs with what I said is long distance file transfers. So it's not easy to transport multiple hundreds of gigabytes of data every day between two long distance locations. The further away they are, the longer it takes for that transfer to complete. And the reason why, even if you have 10 gigabits on each location, you will never reach that with a file transfer unless you tweak for it. And the reason for that is very simple. The basic file transfer protocols, and TCP in that sense really works like that. It sends a piece of data and it waits for an acknowledgement from the other side before it sends another piece of data. So the longer it needs to wait on that response, it waits until sending more. And of course, as you can imagine, the longer that takes, you will see that your bandwidth is going, your usage is going to go down, your performance is going to go down the longer that file transfer takes. So again, there's tweaks for that, there's optimizations for that, but be aware that if you need to exchange these transfers, distance and latency are definitely a key part. And what we see customers do then, so we expect a lot more demand for not just DIA and broadband, but DIA and private, for example, for specific use cases like this. Second is more growth on data centers. This will not be a surprise for most people. But what is different is where these data centers are being built. So you will see all the news with announcements also from the US, where massive investments going to AI. You will have seen a lot of investment news from the Middle East region, like Saudi Arabia and the UAE, really investing heavily in AI and digital infrastructure. Where we are seeing a lot of growth in data center build-outs is specifically in the Nordics, in Europe, and like I said, in the Middle East. Saudi Arabia is a country that's opening up its doors for more options for people to be present without having to be local in the company or in the country. And the reason for that is, of course, is that in both of these regions, the common factor here is relatively affordable power. Power is, of course, the main driver for the growth of data centers. As I said before, we in the past, you would have a data center with a rack that could do a few kilowatts of energy per rack. These days, a rack that consumes 50 to 60 kilowatts of power is not uncommon. That's like a 20x than what was possible only like 10 years ago. So the scale of data centers is increasing as well. So not just the amount, as you can see on the slide, last year about 110 to 120 were built. Next year, it's expected about 170 data centers will open up their doors. But the power hungriness of these data centers is even more concerning. So this year, in these 110 data centers, about 6 gigawatts of power was built to support it, so 6,000 megawatts. Next year, it's expected that about 9 gigawatts of capacity will be built, so 50% more in not as much data centers. So huge amount of power that is needed to drive these AI data centers. And because in these pockets of the world, with the Middle East and with the Nordics, where power is cheaper, connectivity is not, right? So connectivity is not as common as in the other more typical areas. So if you would build a data center in, I don't know, London, Frankfurt, or Amsterdam, you will have tons of connectivity options. The Nordics, they're a little bit more limited. In the Middle East, it's even more limited. So really plan for how do I reach that connectivity? How do I reach that data center with what type of connectivity is going to be tremendously important. And then, like I already said, we expect a lot of sea cables to open up next year. So the ready for service date for 2026 on these cables is here. So if you check out the website that's mentioned here, Submarine Cable Map shows a nice list of about 30 cables that are going to expand capacity or open up new landing spots. So a lot more capacity is being built specifically around the African coast and also towards the Middle East, all based from Europe. There's also a new cable from Meta that goes all around the world. So it will connect pretty much all of their major hubs on a single cable, which has never been done before, which is quite exciting. So again, a lot of stuff happening there, a lot more capacity being built. And then this is an important part if you're a European company. Compliancy for the NIS2 framework is going to go in effect by December 31st. This will be very important. This will be very integral of how your company operates, meaning that there's going to be a lot of demand for cybersecurity regulation on your IT infrastructure. If you're not compliant yet, this is going to be on the table for next year. SASE is a big driver that helps you become compliant. So, of course, when you start implementing SASE, it's definitely a good moment in time to also look at your underlay. And then finally, we definitely expect a lot more from low Earth orbit connectivity options next year. Amazon, the Kuiper project, will join Starlink as sort of the next big offer of low Earth orbit connectivity. The ecosystem will keep on expanding, and Starlink is teasing that they can do gigabit speeds, where today this is around 220 to 30 megabits. They expect to go up to 1 gigabit by next year, all due to the fact that they have new satellites, sort of the generation 3 satellites that are going in the air now, where they can support a lot more bandwidth in more narrow spots and more coverage. So a lot of things are happening on the LEO space, not even talking about the direct to cell and all the cell phone possibilities that they have there, but just looking at enterprise connectivity, LEO is going to become a much more strategic choice coming next year. And then finally, we'll definitely expect that network as a service, which was the topic of our last webinar, is going to see its first real use cases. So use cases outside of the data center. I mean, so use cases in this data center, there's already plenty, but outside of the data centers, we do expect a lot more from network as a service, where usage-based billing should be on the basis of how you consume connectivity rather than a long-term fixed contract on a certain bandwidth link, for example. And everything, of course, driven by automation, not by a manual process. And that brings us to our vision for 2030. So how do we reach certain goals? To recap, we expect by 2030 that about 40% of all network traffic on the internet will be AI related. That's massive, because if you look at the numbers for today, they're around 1%. And that is real life AI usage. So that is talking to ChatGPT, talking to Claude to produce documents and stuff. The agentic AI world has just come off the ground, and we're definitely seeing a huge uptick in bandwidth and demand that's coming with it. So this is based on expectations from multiple resources that they see 30 to 40% of all network traffic will be AI related, which is a massive which is going to massively change the patterns that we see, because most of the network traffic today is, as you know, video. So streaming video going down to your mobile phone, but with AI, that turns everything around. And that is something that we believe is part of our vision for 2030, where network as a service will be fundamental to any type of connectivity that you will buy, where billing is usage-based rather than contract-based, where neutrality is going to be baked into the offer with neutral APIs that are going to provision and deliver your link when you need it and where you need it. And that is something, of course, where GNX plays a big part. GNX is an ISP aggregator with a big plus. We combine the offers of about 3,500 local suppliers all over the world through a single way of communicating with us. We use one platform called GNX Plus that both our own employees and our customers can use to configure, quote, provision, service, and support a full global WAN estate by themselves with just a few clicks in the platform. Stay tuned, by the way, for next week. We are planning on releasing a major new release of the platform, where the way that you approach the configuration and the design of your services and how you will be presented with these changes will change dramatically. It's a big review that we've been working on for months, so we can't wait to share it with you about next week. Thank you for listening. This was very helpful for you. I hope that this was very helpful for you. If there's any questions, there's definitely time for that.
Thank you, Rick. That was a lot of information in almost 30 minutes. We still have some time for the Q&A. The Q&A is active, not the chat. You should be able to find it on the menu on top.
Thank you, everyone, for joining. Like I said, I hope this was useful for you. I hope you were able to give some insights about what happened in 25, how we believe 2026 will evolve around the world of global connectivity. If there's anything related to this that you are wanting to discuss further, my email is on the slide. Always happy to help out with any questions you may have. I hope you join us next year. We'll definitely be back with more webinars, and we'll see you then. We see questions.
Yes.
Very good.
All right, I'm muting myself again. Yeah, sorry, we were missing some of the Q&A. I hope you guys are still around. Somebody's asking who do you see as the winner in the next 5 years? Carriers are still dominating? It's a personal opinion.
No, that's a very good question. Do I still see carriers winning? I don't believe so. it's going to be a mix. So what you're seeing today is that there's a few of these huge global carriers that all of the big enterprises will work with. That will continue to be the case because large companies would like to do business with other large companies. What we do see is a huge market just below that top level that is open for exploring a lot of opportunities. Where and I mean that level below that is going to be again huge companies with billions of revenue and thousands of employees, but still not that like top 100 part of the world. That is going to be the market for these big telcos. Other than that, we see a lot of enterprises moving much more towards a more different approach where they where they want to source or make use of locally sourced circuits. So really thinking more local where you're still a global company. And that's going to be even more complicated moving forward because the offers in the world are going to keep changing. So in summary, yes, they will still be around, but not as impactful as they are today. Thank you, everybody, very much for joining. I hope to see you around. Please watch your inboxes for new invites for more webinars, and we'll see you then. Bye-bye.